Hello, you're welcome back to SPSS Intermediate Training. And we just concluded lesson one, and this is lesson two. If you've not interacted with previous videos, there are just three in lesson one. You can please start from lesson one. All right. So, again, my name is Timothy. This is my email number and my email address. This is a corporate email address, and this number is available for questions, further trainings, further clarifications, and all. It's on WhatsApp. All right, thank you. So now, our last video, we considered this. I said I was going to bold and make it, give it a font color of red. All right, so that's done. All right, so now lesson two. Overview of statistical procedures. We'll be looking at types of data, exploratory data analysis, descriptive data analysis, and data visualization. So from types of data, we'll go to data visualization. Then we have these two. So we have the three videos in lesson two. All right, so we go straight to types of data. Okay. So here we have the data. For every research, every investigation, um, even if it's for sole of data collection, you have to understand the rules guiding how data should be collected. A sound data analysis, which leads to result, policy makings and decision makings, um, has a strong, good foundation of data. I don't know how to put that better, but your data has to be collected in a way it can give you the appropriate analysis and results. And data collection, data management is the foundation of everything. If you have bad data, it's like having foundation, and like the Bible says, if the foundation be destroyed, what can the righteous do? As analysts, you get different people bring already made data, and they want you to perform magic. No, it can't be done. Most of those cases, the data is already dead, the analysis is dead, so you might just have to find your way around it. But here we are going to be learning why and how to collect data. All right, so data is divided into two broad categories. This applies for any software, for any for any. It's just general. It's general. So in different software, you can call them different names, but this is the broad classifications. So we have numerical data and categorical data, also called quantitative data. Numerical is called qualitative data. Categorical is called quantitative data. All right, so let's start from categorical. In categorical, we have ordinal data. So ordinal um, talks about categories with an implied order or placement. Implied order or placement. Example is the Likert scale. If you've ever done a questionnaire before or attended to a questionnaire, you see things like um, from 1 to 5, on a scale of 1 to 5, show us how well you agree or disagree with the statement. 1 being strongly disagree, 5 being, so that's an order. 5 is strongly agree, which means, well, according to, it depends on how this question is structured. If it's structured in a positive way, then strongly agree means that you have 5, you have the highest score. All right. Race. In a race, the first person to get to the finish line, either person or car or horse, is the first. It shows us the position of such entity. We have election. In an election too, we said the first wins, you know. So those are ordinal data when you are reporting first, second, third. In schools, while we're younger, we have positions like first position, second position. So if you have to record that, that's an ordinal type of data. Rank also, you have to rank something who cooks best from Miss A to Miss Z, who cooks best. So one person has to be the first and one person has to be the last. So that position, the ordinal data tells us the positional placement of items or entities in a particular distribution. I hope you understand that. All right. So we also have still under categorical, we have the nominal data. Now, nominal data, ordinal is simple because we have numbers, we are reporting numbers first, second, third, fourth, fifth. 55 tells us this person comes after 54. But in nominal, we have named categories, e.g., for example, sex is boy or girl. So how do we analyze boy and girl? So what we do is we give them numbers. One for boy, two for girl. Basically a number you won't forget. If you're using softwares like Excel, you have to have a coding note somewhere where you would write down those numbers so you won't forget. One for boy, two for girls. One for boy, two for girl. Then so those numbers are not just numbers. They have meaning. So everywhere you see one, that means it's a boy. Everywhere you see two, it's a girl. That's nominal. So in SPSS, that's quite simple. We've done that while we're entering the questionnaire. You can go back to it and see that it's a nominal data. Then sport uniform number. Yeah, that's a very good example. Some on some people's jersey, you see um, number one. A keeper can be number one. Someone else can be. So it really doesn't mean this person is the first. It does not mean the captain has must wear number one. No, it just means it's just a number of identification. I think that's better. A number to identify um, a person or what the person does. So in nominal data, nothing is greater. It's just identification. One for boy, two for girl. Does not mean a girl has higher weights of two. A girl is more than a boy having one. No, it is just a way of identification. All right, discrete. Okay, now we are under numerical qualitative data. Now, discrete data is under numerical. It's only particular numbers. So, example is how many cars are in a compound. We can decide to collect a street data or an area, a community data of how many cars in a compound per house. So the things we'll be writing are whole numbers like 5, 7, 2, 1, 0. So that's discrete. It's discrete. It's not, it doesn't have any spillover. It's either 7 or 8 or 6 or 5. Just brief like that. Household size. Your household size can be 7 or 10. It can be 5.3. It can be 2 points something. Then we have continuous data still under numerical. This is any numerical value. It's measurements. Example is weight, height. Okay, I didn't write that height well. Weight and height and BMI and income and so many more. GDP, um, um, viral load, and so many more. All right. So now, when collecting your data, a a proper for to measure so that you can have different types of interactions, you can have different types of what is it called now of analysis. Your analysis can be robust. It's ideal to try to as much as possible have your data frame measured in different types, at least two different types of data here, either continuous and nominal, continuous, ordinal, so as to at least is to be able to see interaction within effects, within factors of the data. Now let me quickly talk on some things that might be confusing, the idea of discrete and nominal, sometimes they are used interchangeably, and sometimes it doesn't really matter. All right. So for discrete, example of discrete, how discrete and nominal can be, example of how discrete and nominal can be confusing is, here we said how many cars. So if we have a column for number of cars per compound, we could have things like 1, 2, 0, 1, 2, 0 in an area where we have average income earners. We'll have something like 0, 1, 2, 2, 1, 0, 2. Between 0 and 2, you hardly see a compound that has 3 cars. Now, if you look at it well, it might also look, if men seeing the data, you would think it's a nominal data because after all it's no more than 3 entries. All the entries under that data set is just 0, 1, 2, 0, 1, 2. So it's easy to think that 0 stands for something, 1 stands for something which is nominal, and 2 stands for something. So in fact, some softwares can misinterpret it, especially when you don't specify, when you don't give them meanings. So a rule of thumb is to no difference between nominal and discrete. Nominal, the numbers appearing in a nominal data has hidden meaning. One is not one. One is boy in nominal. Two is girl, or whatever you choose to represent them. So a number is really not that number. You can't. I can't say 2 times 1 for a nominal data and say 2 because I said 2 times 1. So a boy becomes a girl. No. 2 times 1 means 2 boys. Me, if there's anything like that. If I add 1 to 1, it becomes 2 boys. I can't have 1 plus 1, so it's two. A boy plus a boy becomes 2 girls. No. That's the difference between discrete and nominal. Again, you rarely see something like this, discrete and continuous. There can be some kind of conflict. Example is shoe size. Shoe size, we have say 14.5, 5.3, 5.2, and so on. So you might think, oh, that should be continuous. But the problem about shoe size is you can't have 14.1, 14.2, 14.3, 14.4. No. If shoe size is discrete because you the shoe sizes have been categorized. So if you are wearing 4.5, you'll be wearing 4.5. You hardly see a 4.6 shoe size if there's a 4.5. Do you understand? Okay. So our next class will be talking on about having data visualization. What type of charts can we plot given these kinds of um, of data. Remember, two broad categories: numerical, which is same as qualitative; categorical, same as quantitative. And I also need to mention that your having a good knowledge of data will also help you to identify what type of statistical procedures analysis you should carry out in to get results. Because when you have a discrete two discrete data, then there are types of um, analysis to carry out for those type of data. When you have two continuous type data, you have another other types of data analysis you can carry out on those types. When you have a continuous, a discrete, two continuous, a discrete, a dependent variable, and so on. Those are things that determine what type of test to carry out. All right. So as I was rounding up, numerical is also known as qualitative. So we have qualitative data analysis and we have quantitative data analysis. You can see it's actually they have those type of analysis depend on the type of data. Then under numerical or qualitative, we have continuous and discrete. Under categorical, we have nominal and ordinal. So all right. Thank you very much for